Okay, so today we're going to be dealing with coordinate geometry. Chapter 9 is all about coordinate geometry. So we're going to be applying geometric properties, or we're going to be determining geometric properties based on coordinate positions of vertices. So graph paper will be necessary. Using graph paper will be important. Using straight edges to help you straight lines just helps to make everything kind of work better and more understandable. If you take a look at example 1 here, it says find AB. Recall with geometry, when you're given two letters with no bar over top, it means the length of AB. So find the length of AB, find the midpoint of AB, and determine the angle made by AB and BC is 90 degrees. Determine if it is. So a couple formulas to be required in this section. So the distance formula between 2 points in the plane says that the distance equals the square root of the difference in the x's squared plus the difference in the y's squared. Midpoint formula tells us the midpoint is going to be an ordered pair. It'll be x1 plus x2 over 2, y1 plus y2 over 2. And then the slope formula, the slope between any 2 points in the plane is y2 minus y1 over x2 minus x1. Those three formulas will be used frequently in this chapter. We've seen all three of these formulas this year. You would have seen them last year in Algebra 1. They're just frequently used formulas within coordinate geometry, use of the coordinate plane. Okay. In every case, the x of 1, y sub 1, x sub 2, y sub 2 just represents two general points. Every one of those formulas is referring to just two generic points on the figure or whatever we're dealing with. Looking at this particular figure, we have point A, point B, and point C. Position based on the origin is what gets us the order pair. So point A is 1 to the right and 1, 2, 3, 4, 5, 6 up. So 1, 6 is that coordinate. Point B is 3 right and 1 up. And point C is 1, 2, 3, 4, 5, 6, 7, 8 right and 3 up. So we just established the ordered pairs of each one of those points. Then we have the x of 1, y sub 1, x sub 2, y sub 2, in this case x sub 3, y sub 3, if you will, of every one of these points. All right. Hopefully you guys all wrote these formulas down on your paper, because again they're going to be used frequently throughout the entire section. So it's a nice little reference page. Come back here when you need them. All right, so I just take these formulas and shrink them up. Get them out of my way. Stick them over here. So when the problem tells me to find AB, the length of AB, I'm going to focus on point A, which is 1, 6, and point B, which is 3, 1. And I'm going to apply the distance formula. So the length of AB is going to equal the square root of that structure. So if I'm applying the distance formula, that's what my work's going to look like. Every single time, what I'm trying to find equals, and then the square root of that structure. Everything written in purple is going to be on my paper every time. The name might be different, but that part is going to be the same every time. And then I simply want to figure out what goes in those parentheses. Now this is the official formula, x2 minus x1, y2 minus y1. All x2 minus x1 and y2 minus y1 is the distance between the x's and the y's. So if I look at my x's, I've got 3 and I've got 1. How far apart are 3 and 1? 2 apart. So that's what goes in these parentheses. You can subtract 3 minus 1, 1 minus 3, it's either 2 or negative 2. When you square 2, you get 4. When you square negative 2, you get 4. So it doesn't matter positive or negative. So for me personally, I always put a positive number in that parentheses. But again, that's the question I'm simply asking myself. I'm trying to do distance. How far apart are the x's? 1 and 3 are 2 apart. How far apart are the y's? How far is it from 1 to 6?
5.
It's 5, so that's what goes there. So again, the distance formula officially is written over there, but again, x2 minus x1 is just how far apart are the x's. y2 minus y1, how far apart are the y's. That's what you're trying to fill in. Then you just do good math. So the order of operations here tells me I'm going to take the square root of, I'm going to square both pieces. 2 squared is 4, 5 squared is 25. Even if these were negative numbers, when you square them, become positive. So again, I just write positives every time, regardless. So square the numbers, 2 squared 4, 5 squared 25, and then you add them together. So the square root of 29 is the answer. Okay. Depending on if they want the exact answer or an approximate answer. If they want an approximate answer, I just type in calculate square root of 29. It spits out 5.39. So AB is 5.39 or square root of 29, take your pick. And again, just for the sake of what they're asking for, exact answer, square root form, approximate answer, decimal form. So again, if they say find the exact answer, leave it in square root form. If they say find the approximate, go ahead and go decimals. If they don't specify, take your pick. They're both right. Part B of the problem says find the midpoint of AB. All right, so midpoint is the midpoint formula over here. We're going to add the x's divided by 2, add the y's divided by 2, and we got AB, which is this. So the midpoint's along here somewhere in the middle. So the midpoint of AB is going to be something over 2, something over 2. So again, anytime I'm doing midpoint, that's what I'm going to have looking at. I'm going to have that on my paper. That's how you find midpoint. And all midpoint is an average, and you average things by adding and dividing by 2. So if you have midpoint and average kind of equivalent in your brain, I'm going to average the x's, so I'm going to add them together. So 1 plus 3 is 4 over 2. 6 plus 1 is 7 over 2. Okay, so again, what's in purple is going to be there every single time. And then the blue is just whatever the sum of the x's and the sum of the y's is. So 1 plus 3 on top of that, 6 plus 1 on top of that. So the x's are first, 4 is first, the y's are second, 7 is second. And then I simply evaluate, so the midpoint of segment AB is going to be 4 divided by 2 is 2, 7 divided by 2 is 3.5. Take a look at the point 2, 3.5, 2, 1, 2, 3.5 would be right there. That seems to be in the middle. So again, that's a quick check on a midpoint. It has to lie on the segment, and it should look like it's halfway along. All right, so that looks like the midpoint. That seems reasonable. All right, finally, it says determine if the angle made by AB and BC is 90 degrees. Now, we have all of the stuff you learned in Chapter 8 about SOHCAHTOA, right? And law of sines, law of cosines, all that stuff. So all that stuff's usable in these problems. I have the capacity using the distance formula to find the length of this side, the length of that side, the length of that side. So I can get side, 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 do a whole law of cosines things here, right? But for a 90-degree angle in particular, that means that AB and BC would be perpendicular to one another. So the easiest way to determine a 90-degree angle is with just slopes. I'm going to find the slope of AB, I'm going to find the slope of BC, and see if they're opposite reciprocals. So if lines are perpendicular, their slopes are opposite reciprocals of one another. If lines are parallel, what's true about parallel line slopes? Anybody remember? If lines are parallel, what's true of their slopes?
They're equal.
They're the same, right? They're equal to each other. So perpendicular lines, parallel lines, we have the ability to determine that using slopes. So anytime we deal with that kind of question, do lines make a right angle? Are two lines perpendicular or parallel to one another? Slopes are opposite reciprocals for perpendicular. Slopes are equal for parallel. So if I look at the slope of AB, and notice the lettering here, capital M for a point, lowercase m for a slope. The slope of AB, if I apply the slope formula here, point A or point B is point 1 or point 2, it doesn't matter, but the order of subtraction matters in this formula. I'm going to do this is point 2. I'm going to call this point 1. And the formula says I'm supposed to take the second y minus the first y over the second x minus the first x. So if this is point 2, the second x and y, this is point 1, the first x and y. If I do y minus y, it's going to be 1 minus 6 on top. And x minus x is going to be 3 minus 1 on the bottom. So notice that the 3 and the 1 both came from point B, and the 3 and the 1 are both in front. And the 1 and the 6 both came from point A, and the 1 and the 6 are both in back. All right, so if I subtract, I'm going to get 1 minus 6 is negative 5, and 3 minus 1 is positive 2. So the slope of segment AB is negative 5 halves. If we look at the slope of BC, I'm going to keep this as point 2. I'm going to call this point 1 for the sake of BC. So the slope of BC, second y minus first y is 1 minus 3. Second x minus first x is 3 minus 8. 1 minus 3 on top is negative 2. 3 minus 8 on the bottom is negative 5. Two negatives make a positive. Okay, so we take a look at the slopes. Negative 5 halves, positive 2/5. Opposite meaning different signs, reciprocals mean flip the fraction. So you can see that the signs are opposite. 5 halves flips to 2/5. Those are opposite reciprocals. So I know for a fact that AB and BC form a right angle. So angle B, measure of angle B is 90 degrees. Okay. So now once I know that's a 90-degree angle, again, we aren't specifically doing this with this problem, but we know the length of AB is the square root of 29. We know this is a right angle, right? I could, figure out the length of this piece also maybe, and all of a sudden I got two sides, and I could be starting to find the angle measures up here at angle A and angle C. Use the law of cosines, even if I wanted to, or SOHCAHTOA, I can find AC. All right. So keep that in mind that once you get the right angle, SOHCAHTOA is usable. If it's not a right angle, then you still have law of sines, law of cosines. With the distance formula, you have the capacity to find the length of any side. You can find any missing sides or angles in any picture that you look at.